Hello everybody. This is Unit 2, Day 3. Again, we are still in the area and volume unit, but before we start talking about volume, we have to first talk about area. All right, and might as well talk about perimeter as well because there is a difference between the two, and it's important that we know what the difference is. Okay, so recall the area of a rectangle, right? If you don't recall, area is equal to base times height. So the area of ABDC, or we could call this ACDB, right? When you're naming these shapes, okay, either go to the left and go all the way around, or you go to the right and go all the way around, but you have to name those vertices in order. Okay, so you can either call this rectangle ABDC or ACDB. All right, now this length over here is, is 4. This length over here is 5, and so the area of our rectangle is 4 times 5, which is 20 units squared. Which, how many 1 by 1 boxes we see in there? We see 20. All right? So that's what it means to be units squared. We have 20 1 by 1 square units. All right? So, that being said, all right, I will now draw a line segment from point B to point C. This will divide our rectangle into 2 equal parts. All right, in actuality, we now have 2 congruent triangles. All right, and when we get to the triangle units, I'll emphasize on this part more, but what that means, when I say I have 2 congruent triangles, that means all of the angles are the same. Right, and all of the sides are the same. All right, so this side is congruent to this side. This side is congruent to this side, and they both share that one side, so that's obviously congruent to both. And then all these angles are the same. Okay? All right. Well, the opposite angles are congruent, right? So this is congruent to this one. This is congruent to that one, okay? What we call alternate interior, right? Alternate interior angles, okay? That would be 1 and 2, and then 3 and 4, okay? All right, I'm going a little bit extra there, but anyway, all right? So that's what it means to have 2 congruent triangles. So by drawing a line from B to C, I have now created 2 congruent triangles. Okay, just know that all of their angles and all of the sides are the same. All right, now that means the area for each triangle, right? So if this was originally 20, right, for the whole piece, and I just divide it into 2 equal parts, that means this area, not 20, is 10 units squared, and this one is 10 units squared, right? Add those together, and we still get 20 square units, which is what our original area was. All right? Now, as we continue on here, I will now take one of them away so that we only see one of the triangles. So now we're looking at just triangle ABC or triangle ACB, whichever you name to prefer it. All right? Now, the area of triangle ABC is equal to 1/2 4 times 5, which is 10. So therefore, all right, what we've just shown, right, at least in this particular case, and what I'll just say for all cases, all right, is the area of any triangle is 1/2 base times the height. Okay, and that's derived from the fact that in this particular case, if I took that triangle and put it on the other side, kind of reflected it over line BC, we would get our full rectangle. All right, so the area of any triangle is 1/2 base times height. All right, so height can also be referred to as altitude. All right, so sometimes they'll say the altitude or the height. Just know that those 2 names are interchangeable. They mean the same thing. So height and altitude are the same thing. All right. And so the last part, all right, I want to find the perimeter of this guy, right? So I found the area. The area is 10 units squared. In order to find the perimeter, right, well, this is length 4, this is length 5. Okay, so all we're missing is that side right there. Now this is a right triangle, which means in order to find this side, I'm going to have, in order to find the length of that other side, I'm going to have to use Pythagorean's theorem. Okay, what's Pythagorean's theorem? A squared plus b squared equals c squared. Now remember, your c is always opposite your right angle. Okay, so it doesn't matter if you mix up the a's and the b's, but just don't mix up that c value. The c is always your hypotenuse, or again, that side located directly across from your right angle. All right, so this is 4 squared plus 5 squared equals c squared. And so I get 16 plus 25 equals c squared. So I get 41 is equal to c squared. Take the square root. C is equal to the square root of 41. So now this length right here, square root of 41. Doesn't say anything fancy about keeping it in radical form, so I'm going to go 9 plus 4 plus square root 41. Not 9 plus 4, sorry, 9 plus square root of 41. I don't know what I said there, but yeah, 5 plus 4 is 9. So our perimeter is 15.40312424 units. Okay? So that's how you find the area of a right triangle. Okay? Now, of course, not all triangles are right triangles. Sometimes the height or altitude of a triangle is not one of the sides. Okay? So if you look up here, our height, right, is found by just looking at one of the sides, right? And we have it on a nice coordinate graph, so I was able to pick out how many units or what was the length of that of either side, right? Sometimes it's not that simple. All right, so here are 2 more examples how to find the area of a triangle. Now, in this case right here, okay, we don't have a right triangle, right? This is actually what you would call a acute triangle, right? Because all of our angles are technically less than 90. Okay? Just if you don't remember me discussing that. So anyway, our base, right? So what is our base here? Well, our base is 6. Now, what is our height? Now, we can't use our diagonals. Just like with the parallelograms, okay? You cannot use your diagonals for a height. All right? So therefore, that's out. But what you can use, and just like with the parallelogram, is you want to create a perpendicular line either inside the shape or outside the shape. Okay? And by creating that perpendicular line with our base, right, that accounts for our height. So as you can see, I already did that here, right? dB is equal to 4. So our height is 4. All right, and so the area of our triangle is 1/2 6 times 4, which is 1/2 of 24, which is 12 units squared. Okay? All right. Now, I already did. The area of triangle ABC is 12 units squared. Okay? I also want to point out, all right, is that if I were to kind of create this same exact triangle, if I were to reflect it over this line, so if I reflect the same triangle over that line right there, what I get is this shape right here. And as you can see, what kind of shape is this? Well, this is a parallelogram, right? Okay, and how do we find the side of a parallelogram? or find the area of a parallelogram? Well, we would have to locate one of our heights here, right? So we would have to draw some sort of perpendicular line here, right? And then you could take that triangle and put it on the other side, right? That represents our height. So what is happening here is, even though this isn't a right angle, right? They're not right triangles, right? Even though, I mean, ignore this height here, okay? All right, this isn't a right triangle, all right? Even though you can kind of see two right triangles. What we're really taking the half of is not half of a rectangle, but half of a parallelogram. Okay? So that's what we're really finding the half of. So if I wanted to guess, you know, educationally, all right, what the area of this parallelogram is, I would say the area of this parallelogram has got to be 24 units squared, right? Because this triangle is 1/2 of that parallelogram. All right? So these triangles are either half of a square or it is half of a parallelogram. Parallelogram. Okay, half of a square, or it can be also half of a rectangle. Okay, so that is where they're coming up with this 1/2 base times height. It's either half of a square, half of a rectangle, or half of a parallelogram. All right, so let's move on to the last one. So what's different about this one is we're going to have to actually come up with our height by, like we did with parallelograms, drawing a nice perpendicular line on the outside of our triangle. Okay, we could certainly do one here, right? But, you know, I don't know. We would have to do too much math there, right? So you always want to go for what's easiest. And what's easiest? Draw a nice perpendicular line from B down to our base, right? Perpendicular with our base. So, all right, our height here then is 1, 2, 3, 4. Our base is 1, 2, 3, 4, 5. So we're going to go 1/2 base times height. So we get 1/2 20, which is 10 units squared. Okay, so our base was 5, our height was 4, and the area of triangle ABC is 10 units squared. And again, if I take this piece right here, this triangle, and I reflect it over this line right here, right? So I kind of just take that same triangle and put it on the other side. Looks like I create a parallelogram. And this one, we can find the area of, right? So let's just make sure Mr. Kea isn't pulling stuff out of his butt here. All right, so our height of this parallelogram is 4. Our base is 5. And so the area of a parallelogram is base times height. So 4 times 5, which is 20 units squared. So the area of triangle ABC is half of parallelogram ADBC. Okay? And so that is where they're kind of coming up with that formula. It's to find the area of a triangle. Again, it's either half of a rectangle. More important, let me just write this a little clearer, right? So we'll say all right, so the area of a triangle is either 1/2 of a rectangle, it's either 1/2, the the area of a rectangle, right? 1/2 the area of a square, or 1/2 the area of a parallelogram. Okay? And so that's where they're coming up with that formula. So if you can just remember 1/2 base times height, and just know sometimes your height isn't given to you nice, like this problem up here, right, with this right angle. Sometimes your height has to be found by either drawing a perpendicular line inside your shape, or like we did down here, on the outside of the shape. Okay? So for homework, I want you to try those problems right there. So there is 6, and good luck, you guys.